Hi guys, good morning. Just one more time, the expectations for today are that you're taking notes on your paper, write down the problems and pictures where necessary, and when I ask you to pause the video, please do that and complete the work on your own. All right, so getting started on our do now, I want you guys to use the quadratic formula to solve each of these equations. So go ahead and pause the video and do that. All right, and when you do that, you should have gotten these as your answers. 1 and negative 1.33 for the first one. For the second one, you got 1/2 and negative 5. I'll do the first one so that we can see and double check our work. All right, so our equation for our quadratic formula is x is equal to negative b plus or minus the square root of 4, of b squared minus 4ac all over 2a. And you should remember that from the song that you guys listened to yesterday. When I do that, I'm just plugging it in a, b, c, a, b, c, where b right here is an invisible 1. All right, so when I do that, I'm going to do x is equal to negative b. Negative b is negative 1 plus or minus the square root of b squared, so 1 squared minus 4 times a times c. A is 3, b is 4, all over 2a. All right, and when I do that, I like to tackle the square root first. So right here is what I'm going to do in my calculator. You guys, like I said, can use your Google applications or Desmos or whatever if you don't have a calculator at home. Square root of 1 squared minus 4, this minus is important, times 3 times 4 equals, and see, I probably did something wrong here. So it's a 1 squared minus 4 times a times c. Okay, so this is not regular 4, it's a negative. Negative 4. Let me go fix that. Square root of 1 squared minus 4 times 3 times negative 4. That's going to give me 7. All right, so I have plus or minus 7 as what's under the square root, and then I'm going to carry everything else down over 2 times 3. And I'm going to simplify that. 2 times 3 is 6, so I'm just going to write that as 6. Okay, when I do that, I have a plus up here and a minus down there. This will be negative 1 plus 7 over 6. The bottom one's going to be negative 1 minus 7 over 6. And let's simplify that. This will be negative 1 plus 7 is 6 over 6. The bottom one's going to be negative 1 minus 7, negative 8 over 6. And when I simplify these, this equals 1, just like I have here. And this equals negative 1.33 continuous, just like I have there. So make sure that you did number 2 correctly, and you should have gotten 1/2 and negative 5. All right, so nothing new really from yesterday, except for we're going to use the quadratic formula and apply it to word problems. We're going to go over a focus question and some real quick notes on the discriminant and word problems. All right, so our focus question right here is, Anahi's trying to hit the crossbar of the soccer goal. The crossbar is 8 feet high. She shoots with a velocity of 22 feet per second. Write the equation for the scenario and what does each of the numbers represent? Against the force of gravity, what's the maximum height of Anahi's shot? And will her ball go over, below, or hit the crossbar? We've done this many, many times, so I'm going to ask you guys to pause the video and go ahead and complete this yourself. This is Desmos Active, so go ahead and use that application on your Chromebooks. All right, when you do that, your equation should have been this. Remember, we have gravity, the initial velocity, and then the starting height, which is on the ground, so 0. On Desmos, I can easily graph this parabola, and it gives us all the information that we need. This is the vertex, so that's going to be the maximum height. And then this is the 0 where it starts off, and this is the second 0 where it hits the ground. So to answer the question, the maximum height of Nahishat is 7.56 feet. That's her maximum height, which she attains in 0.69 seconds. So that's the vertex, that's the maximum. And then will her ball go above, below, or hit the crossbar? Because it's at this height and this is the height of the crossbar, it will go below. This we were going to do yesterday, but I wanted to save some time. It's called the discriminant, and this is the equation for it. B squared minus 4ac. You see that right here? And basically what the discriminant is going to tell you is if there is one intersection for your x-intercept, none, or if there's going to be two. So two solutions, one solution, or no solution. All you need to do is plug in your values here, and if there's two solutions, this number is going to be greater than 0. If there is one solution, this number is going to be equal to 0. And if there's no solutions, this number is going to be less than 0. I'm just going to do one example really quick. I don't want to spend too much time on this. All right, so using this as discriminant, square root of b squared. B is going to be the value 7, so I do 7 squared minus 4, and then I do the a value is 2, and then times c value is negative 15. And guys, all of this looks like the quadratic formula. You know this is part of the quadratic formula. And all I do is put this in my calculator. Square root of 7 squared minus 4 times 2 times negative 15. All right, and this is going to be equal to 13. So going back to this visual, if the number is above 0, and I know 13 is greater than 0, then this quadratic right here is going to have two solutions. That's it. That's all you need to know. For this one over here, I'm going to plug this in. Square root of b squared, 8 squared minus 4 times a, which is negative 2, and then times b, which is negative 5. Plug this into your calculator. And you're going to have 4.9. Since 4.9 is greater than 0, this one's also going to have two solutions. And that's it. That's all I want to focus on for discriminants. All right, so let's talk about how this relates to actual real-world scenarios. This one says, consider the following graph, which describes the height in feet of a frisbee above the ground and the time it's in the air. What is the initial height of the graph? Okay, so let's pause, and I want you guys to first copy down the picture and the question. So go ahead and pause the video and do that. All right, so let's take a look. The first thing I want you guys to do is to label your graph. So I know on the bottom right here is my x-axis, is my independent variable. So you should label that as time. And time in this scenario is being measured in seconds. On the side, our y variable is going to be height, and it tells us it's being measured in feet. All right, so make sure you have that labeled. What is the initial height on the graph? So initial means in the beginning. So I take a look at the beginning of the graph, which is going to be right here. So what is the initial height? If this is time right here, the 0, then the 25 is the height. So the initial height, or the beginning height, is 25 feet. What is the equation for the axis of symmetry? Okay, So let's take a look at the axis of symmetry. The axis of symmetry happens at the vertex, and it cuts the parabola, so it is symmetrical. So something like, let's get it right, something like this, right? So all I need to know is what is the equation of that line? It's in the form x equals, and the x value is 27. So this is our axis of symmetry. How long was the frisbee in the air? So I take a look. This is where the frisbee begins. It flies up, reaches its maximum height, and comes all the way down. So how much time has passed? If I know time is running on the x-axis, that's how long time has passed. So if it's 0 here and the seconds are running, it goes all the way to 65 seconds. So it's in the air for 65 seconds. When it's the highest, it's gone. So we just measured in pink the time on the x-axis. When it asks how high it is, we're measuring the height in feet on the y-axis. So it's going all the way up to this value. And what is this value? It goes from 0 to maximum height of 27. So the highest it went was 27 feet. And then lastly, when was the frisbee at its highest point? This is the verbiage right here, that word, when. So if I'm talking about my maximum, my vertex happens right here. Well, we already said it's at 27 feet, but when is asking for the time. So let's take a look at that ordered pair. That time is happening when, whoops, just kidding. This time is actually 27 feet. And this value right here is not 27 feet. It's the y value, and 70 is the y value. So the highest value is actually 70 feet. And then the time when that occurs is 27 seconds. Yep, 27 seconds. So make sure you understand the x and the y so you don't confuse them just like I did. All right, so go ahead and copy down this picture and this question for the second example. A diver jumps from a springboard, and the motion is given by this equation where t is time and h is height. So go ahead and pause and then copy down this graph and these sets of questions. All right, so in reading these questions, let's figure out which ones we want to do first. The first one says sketch the graph. Now I need a lot of information to do that, and I don't have all of it yet, so I'm going to hold off on number 6. Number 7 says, how high is the springboard? I can do this one easily because it's already in the equation. How long does it take for the diver to hit the water? So you don't have to copy this down, but if I imagine that, that would be towards the end right here. I haven't solved that yet, so we're going to take a pause on this. The maximum height of the diver, well, that's just my vertex equation. I can solve that. Number 10, how high is the diver after 5 seconds? I'm just plugging in a t value. I can do that first. When will the diver be 9 feet above the pool? That one's a little bit more difficult because I'm plugging it in for the y value and solving. So I'm going to hold off on that. How far does the diver fall, and how far does the diver rise? That one's going to be dependent on the graph. So we're just going to do 7, 9, and 10 to begin. So 7, 9, and 10. All right, so we're going to come back to this. I'm going to go to a screen where it's smaller. So number 7 says, how high is the springboard? Well, that's actually pretty easy. That is the starting height. So where is it beginning? And I know that my C value is where it's in the beginning. So that's all I have to put. My springboard begins at 5 feet. And if I want to label that on my graph, I can start by doing that. It begins at 5 feet. Something that you also want to start off with is labeling the x-axis as time in seconds, and then labeling your y height in feet, something like that. All right, next question. What is the maximum height of the diver? Well, we know maximum means vertex, And my vertex formula is x equals negative b over 2a. So all I'm going to do is plug that in. X equals negative b is 15, over 2a. Remember that a value is not 8, but a negative 8. This becomes negative 15 over negative 16. And on my calculator, when I do that, negative 15 divided by negative 16, I get an x value of 0.9375. I'm going to round that to 0.94. My x value is time. So this is 0.94 seconds, but it's asking for the maximum height. So I'm looking for a y value to give me my height in feet. All I do is use this equation and plug in my t value or my x value of 0.94. Negative 8 times 0.94 squared plus 15 times 0.94 plus 5. And when I do that, I get a maximum height of 12.03 feet. 12.03 feet. So for number 9, I have a maximum height of 12.03 feet. And since I have that information, and that's my maximum, I'm going to go ahead and, label this on my graph. So maybe something like this, where this would be 12, around 12, and this would be around, 0.94? So that's my maximum. So it's starting at 5 on the springboard and going to a maximum height of 0.9412. All right, so I did 7, 9, moving on to 10. How high is the diver after 0.5 seconds? All right, so if x equals 0.5, all I need to do is use my equation and plug in 0.5. And when I do that, I get 10.5. So y equals 10.5. Remember, x is seconds, y is feet. So how high is the diver after 0.5 seconds? The diver is 10.5 feet in the air, vertical distance or height. All right, so I did 7, 9, and 10. The next one that makes logical sense to answer would be this one. How long does it take the diver to hit the water? If I was imagining this graph to continue, it would look something like this. And that question number 8 is asking what this value is when this diver hits the water. So, since we're looking for a solution or an x-intercept, the easiest way to do this is to use the quadratic formula, which if we remember is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so when I do that, let's figure out what this is. B value is 15, so negative 15 plus or minus the square root of b, 15 squared, minus 4 times a times c over 2a. A value is negative 8, c value is 5, and this is over 2 times a, negative 8. All right, and I want you guys to pause the video and go ahead and do this on your calculators. All right, so under my square root, I got 19.6. So this becomes negative 15 plus or minus 19.6, and then 2 times negative 8 is negative 16. This becomes 2 different values for the plus and the minus. So I'll do the plus to begin. Negative 15 plus 19.6 over negative 16, and I'm going to get negative 2.29. That's for the plus. For the minus sign, I'll do that next. I get a value of 2.16. All right, so when it's asking, how long does it take the diver to hit the water? My options are negative 0.29 seconds or 2.16 seconds. If I take a look at my graph, it doesn't make any sense for the time value to be negative. So if I were to continue this value would match the one that we solved in our quadratic equation, and it'd be x equals 2.16 seconds, which will be our answer for number 8. All right, so we can answer number 12 and number 13 right here. How high does the diver fall? So falling means it's going down. Our maximum height is 12. And then the diver goes all the way to 0 feet right here. So the diver fell 12 feet, going down 12 feet. If it's asking for how much the diver rose, we're talking about positive vertical height. So this one was negative. We're talking about how far the diver went from beginning to his or her maximum height. If they went from 5 to 12, that's a vertical distance of 7 feet rising. So we'll skip number 11 for now, and we'll come back to it in a different question. But that's basically the rundown for this entire scenario. All right, I changed my mind. We should actually do number 11. So number 11 says, when will the diver be 9 feet above the pool? So I take my formula that I have, which is negative 8 t squared plus 15t plus 5. And it's asking when the diver is going to be 9 feet in the air. So my height is going to be 9 feet. Basically, to solve a quadratic, I need to set this equal to 0. And to set it equal to 0, I got a minus 9 on both sides. So the equation that I'm working with will now become 0 equals negative 8t squared plus 15t, and then 5 minus 9 is negative 4. So all I have to do is use this equation and use the quadratic formula that I've listed right here to figure out when the diver will be 9 feet above the pool. So go ahead and use this. Oops. And plug it into the equation to see what your x values are going to be. When you do that, your x values should have 2 different numbers. First, you'll have 0.32, and second, you'll have 1.55. So basically, this is saying that when the diver is 9 feet above the pool, time will be either 0.32 seconds or 1.55 seconds. Let me show you why that makes sense. So this is Desmos active, so let's use this and plug in the equation. Negative 8x to the power of 2 plus 15x plus 5. All right, so this is my equation. Look, this matches the vertex that we already found, and the diver starting off at 5 feet on the springboard. So it says in our equation, when will the diver be 9 feet? We know feet is going to be in the y-axis, so let's figure out when y is going to equal 9. So I go up, and I'm getting closer and closer to 9, trying to get it as exact as possible. And yeah, that's pretty close. So something like 9.04. So you can see my x value is going to be 0.32, which matches, yep, what we have right here. Let's look again where the diver is going to be 9 feet. So reaches 9 feet here, reaches a maximum point and comes back down and has to hit 9 feet in height again. I'm going to try to get as close to 9 feet as possible. All right, and then at 1.553 seconds, the diver reaches 9 feet again, and that matches our second quadratic formula value. All right, so on Go Formative, I want you guys to go back and forth between doing this by hand using the quadratic formula and doing this using Desmos. So for example, this one right here, number 3, you can put this into Desmos and do just like we practiced in the last problem, finding the values by just interpreting the graph. Make sure that you do your Go Formative and your exit ticket.